Okay, let's take a look at section 2.5, which is compound inequalities. We looked at inequalities last night and did a few of those in class today. So now let's look at compound inequalities. And a compound inequality would be two inequalities that are joined by an and, or, and or. And a simple inequality just has one that connects them. So when you look at these compound inequalities and you want to graph them, you can put them on the number line. Graph them first so that you can get an idea of what they look like. So A here says that x is less than 6. And it's an and. Okay? So here is 6, here is 9. X is less than 6, x is less than 9. Okay, so when it's an and, both must be true. So this is an and, so both must be true. So when you're looking at the interval where these are both true, you're looking at 6 to negative infinity. So the interval from negative infinity to 6. This time with the 6, you have to think about this because the 6 is not included in that first statement, therefore it is not included in this interval. Okay, the next is an or, which says 1 must be true. So if it's an or, 1 must be true. So we can solve these two. I have 2x minus 9 is less than or equal to 5. So 2x is less than or equal to 14. So x is less than or equal to 7. And on the other side, I'm going to divide by negative 4. And that's going to give me that x is less than or equal to 3. Don't forget, multiplying or dividing by a negative number causes you to reverse that inequality symbol. So now, what this looks like on the number line is I have 7 here, I have 3 here. It says that x is less than or equal to 7. So it looks like this. It's less than or equal to 3. So it's going to look like this. But in this instance, instead of both must be true, we have 1 must be true. So the interval will be from negative infinity to 7 inclusive. Okay, negative infinity to 7 inclusive. The next is an and. So this time we have x is greater than 2 and x is less than 5. There's 2, there's 5. Neither of those are included. Here's my interval. So that is from 2 to 5. So that's the region where they're both true. Because we have x is greater than 2 going this way. X is less than 5 going that way. Where are they both true? In that region in which they overlap. D, x is less than 3 and x is less than 5. Okay, because it is an and, we have to go to where they are both true. They are both true for x is less than 3, so that will be from minus infinity to 3. Next, I have an or, x is greater than 4. There's 4. And then x is greater than 0. And because it's an or, 1 must be true, not both. So you're looking for where either of them exist, and that would be from 0 to positive infinity. So again, or is either, and is both. Okay, when you're looking at those and or problems. We can have the intersection of two inequalities. So let's take a look at this. I'm going to solve each one of these for x. So I have x is greater than 1 and x is less than 1. No, less than 13. I'm sorry. I wondered that didn't look right. Less than 13. So let's look at this on the number line. Here is 1, here is 13. So x is greater than 1. X is less than 13. It's an and, so where are they both true? And they're both true in that region from 1 to 13. Now let's take a look at the union of two inequalities. So we'll solve the first one. Minus 7x is greater than or equal to 7, so x is less than or equal to minus 1. And then 3x is less than 9, so x is less than 3. This is an or. So here on my number line, I have x is less than minus 1, less than or equal to, so that will be included. And then less than 3, and it's an or. So I'm going to have the interval from negative infinity to 3. Now a compound inequality is actually a union, and when we look at this union we're going to get a region where we have one going one direction and kind of one line going the other direction. So how do we solve this when we have two inequality symbols in our statement? What you have to do is do the same operation to each of those three different regions. This region, and this region. So if I want to isolate the x, I have to add 3 to each of those terms. So that's going to give me 1 is less than or equal to 2x, which is less than or equal to 10. I'm solving for x, so I'm going to divide each of those regions by 2. When I'm finished, I will have x is greater than 1/2, greater than or equal to 1/2, but less than 5. So on the number line, here is 1/2, here is 5. X is greater than or equal to 2, but less than or equal to 5. So what region do they share? And that's the region between 1/2 and 5. 1/2 is included, 5 is not. Let's take a look at another one of those problems. Again, I have minus 1 is less than or equal to 3 minus 2x, which is less than 9. I'm solving for x. The first thing I have to do is isolate the term that contains an x. I'll do that by subtracting 3 from each of those regions. So I have minus 4 is less than negative 2x is less than 12. Okay, then I'm going to divide by negative 2. Remember, when you divide by or multiply by a negative number, you have to reverse those signs. So I will have 2 is greater than x, which is greater than negative 6. Now do me a favor and rewrite that from the lowest term on the left up to the highest term. That's how we think of numbers, as going from low to high. So rewrite that as minus 6 is less than or equal to x, which is less than or equal to 2. So when you look at this on the number line, I have x is greater than minus 6, x is less than 2, sorry, that's a 2, going that way. So my region in interval notation would be minus 6, 2, 2. Okay. Did I subtract? I think I made a mistake here. I think this should be a 6. And then this should be a 3. That's a minus 3. So this should be a minus 3 and a 2. You probably already caught that, so kudos to you. I didn't catch it till the end. Okay, let's take a look at D. Again, I have to do the same operation to each of those 3 regions, so I'm going to multiply each region by 2. Please don't leave any off on this one. When I multiply 80 by 2, I get 160. When I multiply that center by 2, over here, x plus 76 over 2, when I multiply that by 2, they cancel. Please don't multiply that numerator by 2. You've defeated trying to cancel the fraction when you do that. So this just stays x plus 76 less than or equal to 89. And I multiply that by 2, I get 178. Okay? Then I'll subtract 76 from each region. And in this case, I will get 84. It's less than or equal to x, which is less than or equal to 102. So my region will be the region from 84 to 102 inclusive, because I have those equal signs underneath the inequality. Okay, let's take a look at the next one, E. Again, I'm going to multiply each region by 2. So that's going to give me 0 is less than or equal to 3 minus 2x, which is less than 10. Solving for x, I have to isolate the term 2x, so I'm going to subtract 3 from each region. And then I'm going to divide each region by a negative 2, which means I'm going to have to reverse those inequality symbols. So I have 3 halves is greater than or equal to x, which is greater than negative 7 halves. And as I said before, write this in order from the smallest term on the left up to the larger term on the right. And in interval notation, this would look like 7 halves and 3 halves with a bracket because 3 halves would be included. F, again, I'm going to multiply each of those 3 regions by 3. That gives me a negative 9 is less than 2x minus 1 is less than 7. Add the 1, so I have minus 8 is less than 2x is less than 8. Divide by 2. And I'll have minus 4 is less than x, which is less than 4. So my region for this one will be 4, 2, 4. Oh, I think by 3, I think I made a mistake on this one. Holy cow. It's lunchtime and I'm tired. Let me erase this part. And I multiply. I added, not multiplied, or I did something strange. When I multiply each of those, I'm going to get 21 here. So I will have 21 divided by 2. And actually 22 divided by 2, which gives me the region from 4 to 11. So that's the region. Sorry about that. Now G, I think G is just a little visually challenging because you have to kind of look at where your inequalities are, because you have a big term in the center, and that's this whole part is the part that's in the center. So if you think about how to start looking at this, the first thing I would do is simplify it by subtracting 4 from each of those regions. So I would subtract 4 here, subtract 4 here, and subtract 4 here. So that gives me a minus 2 is less than or equal to minus 1/2 times x minus 8, which is less than or equal to 6. Now, the next thing you can do is get rid of that fraction, that 1/2, by multiplying each of those regions by a negative 2. Now again, when you multiply or divide by a negative 2, you want to reverse those inequality symbols. So this is going to be 4 is greater than or equal to minus 1/2 times negative 2 will give me a 1, and that makes that x minus 8 is less than or equal to 6 times negative 2. Sorry, I need to reverse that. Then that be 6 times negative 2 gives me negative 12. So I want to reverse that, so I have negative 12 is less than or equal to x minus 8, which is less than or equal to 4, and then I'll add 8 to each of those regions, and I'll have minus 4 is less than or equal to 8, which is less than or equal to 12. So my region will be from minus 4 to 12 in interval notation. Okay? And then we just have a couple of true-false questions, I think, here. It says that 0 is greater than negative 3, but less than negative 2. That would be false. It says the intersection of the region from 3 to infinity intersected with 8 to infinity. Remember, the intersection is an or. No, I'm sorry, that's an and. The intersection is an and. So that would be 8 to infinity, and that would be true. Then 3 to infinity joined with 8 to infinity. That's an or. And so it would be 3 to infinity, so that is false. Number 4, the intersection of negative 2 to infinity and infinity to 9 is minus 2 to 9. So the intersection, again, that's an and. So where do they overlap? They overlap between negative 2 and 9. And you can put that on a number line and see it pretty clearly. Okay, that's it for the video. I'll see you tomorrow in class. Have a nice evening.